Okay, so we're on a new topic now. We are going to be solving systems of equations, and the method we're going to use first today is graphing. Okay, but I want to highlight what this means. What does it mean? So first off, what is a system of equations? A system of equations is two or more equations. Okay, so a system is two or more. In Algebra 1, we're never going to deal with more than two. In Algebra 2, you will see three. Beyond three, maybe four a little bit, but beyond that, it's easiest just to have a computer do these. But we're going to tackle the basics. We're going to have two equations at once. And what does it mean to solve? What does it mean to solve a system? It means to find points. So find, for example, x and y that works for both. Okay? So a system is two or more equations, and what does it mean to solve a system? It means to find the x and y in our case, or whatever variables, v and w or whatever, a and b, but to find the x and y that works for both. There are three different ways that we're going to talk about how to do it. The first way that we're going to talk about today is just to graph. Okay, so it's very easy to see where the point is that works for both when you graph it, and then we'll move on to other methods. So first off, it says again to solve each system by graphing. Check, I don't know if we're going to check our solutions, but let's talk about first off how to solve by graphing. So first off, remember we talked about two different ways to graph. We have slope-intercept. We have slope-intercept. Oops, slope-intercept was y equals mx plus b. Y equals mx plus b. And if you remember, for slope-intercept, we did the begin and move. That was our strategy for slope-intercept. Then we had standard form. Standard form. And standard form was ax plus by equals c. So the difference is you have x and y on the same side. And remember, for standard form, we would find the x-intercept and the y-intercept. Okay, so two different types, slope-intercept and standard. If y is by itself, we do begin and move. If x and y are together on the same side, we find the x and y intercepts. So first off, let's take a look at what are these guys. And it could be one of each. But look here, y is by itself. That is slope-intercept. And again, y is by itself. So it looks like they are both y equals mx plus b. It looks like they are both slope-intercept forms. So the strategy, we are not going to find the x-intercepts and the y-intercepts. We are going to begin and move. Okay? So hopefully we practice this enough. I'm going to do, let's do this first one in red, and I'll do the second one in a green here. Okay, so the first one will be in red. Let's graph this. So we're going to begin and move. Remember, this is our M, this is our B. So M for the first guy. What is our M? It's not X. What's this number in front of X? Well, that's just a 1, right? Our M equals 1 over 1. We write that as a fraction. And our B equals, not 3, B equals negative 3. So let's begin and move. We're going to begin with negative 3. So remember, this is our X, this is our Y. So let's begin with negative 3 on our Y axis. Always the Y axis. So go ahead and put that right there. That's our 0, negative 3. There he is. And then we're going to move. How do we move? Remember, this is rise over run. Rise over run. So positive rise would be up, not down, up, and then right. Right? This is positive, goes to the right. So up 1, right 1. Let's do it from here. Let's go up 1, right 1, dot. Up 1, right 1, dot. Up 1, right 1, dot. You don't have to do this many, but just for fun if you want to. Don't forget you can also go down 1, left 1, dot. Down 1, left 1, dot. But in either case, so take out your ruler or your straight edge and go ahead and make straight line through these guys. And don't forget to draw your arrows to show it goes on forever in those directions, those two directions. All right, so let's take a look at the green one now. Again, we're going to begin and move. So this is our M, this is our B. So let's write it out. Our M is -1/4. You can give the negative to the 1 or the 4. And our B, whoops, our B, I gotta change my tool. Our B equals +2. B equals +2. So we're going to begin and move. So we start with the B. That's a +2, so we're going to start right here. So go ahead and put your dot right there. +2. We begin here. Now we're going to move. Let's think about this. This is -1/4. You could actually, since the negative's here, you give it to either one, but we gave it to the numerator. So it's rise over run. But what is a negative rise? We're not going to go up like we did here. We're going to go down. We're going to go down 1, but see how this is still positive? We're going to go down 1, right 4. Down 1, right 4. So let's go ahead and start from this dot. We're going to go down 1, right 1, 2, 3, 4. Down 1, right 4. I'm off the screen. So instead of going down 1, right 4, down 1, right 4, let's go up 1, left 4. 1, 2, 3, 4. So down 1, right 4, down 1, right 4. If that doesn't work, we'll go up 1, left 4, up 1, left 4. And let's go ahead and draw our line in. Okay, draw the arrows. So let's think about this. Again, to solve a system of equations, you want to find the x and y that works for both. So think about it. These are all the guys that work for the green one. These are all the guys that work for the green one. These are all the guys that work for the red one. This one doesn't work for the green one. This one doesn't work for the green one. This one doesn't work for the green one. This one works for the green one, but this one doesn't work for the red one. This one doesn't work for the red one. There's only one place that works for both the red and the green, and it is right here. This is our solution. This is our solution. So let's think about what x would that be? That would be x equals 1, 2, 3, 4, and y equals 1. So 4, 1 is our solution. 4, 1 is our solution. And to check, we're not going to check all of these, but just for for our sakes right here, let's check this first one. 4, 1. So x, in other words, we're saying x is 4 because that comes first, and then y is 1. So if we do that, let's check. So if x is 4 and y is 1, so I'm going to take this out. You can just watch this. If this is a 4, I'm going to erase this and put a 4 instead. If this is a 4 and this is a 1, where's my erase? This is a 1. Does that make sense for the top one? Does 1 equal 4 minus 3? 4 minus 3 is 1, so yes, it works for this top guy. Let's take a look at this one. So again, x is 4. X is 4. So 4, and y is 1. Does it make sense for the green one? Well, let's see here. -1/4 times 4. These 4s are just going to cross each other out. So we're left with just negative, this is a 1 if you think about it, -1. -1 plus 2. -1 plus 2. Does that give you 1? -1 plus 2, it does. So you can tell that the only combination of numbers that works for both of these is x is 4, y is 1, or 4, 1. All right, let's try another one. Let's try number 2. So again, we have to ask ourselves, we've got a system, we've got two equations. And again, what does it mean to solve a system? It means to find the x and y that works for both. It means to find the x and y that works for both. So let's ask ourselves, what do we have here? Do we have y equals mx plus b, slope-intercept form? Or do we have ax plus by equals c, standard form. Because we have different strategies. Remember, slope-intercept form, we do begin and move, begin and move. Standard form, we find the x and the y intercepts. Well, let's look here. Is y isolated? Is y by itself? Yes. He is here, so this looks like slope-intercept for this guy. Is y by itself? Yes. So it looks like they are both slope-intercept. Both these guys are slope-intercept. We're going to do begin and move again. Why don't I do red for this guy again? And we'll do green for the bottom guy again. And again, we want to find what point works for both of them. So let's go ahead and begin and move. So this is our M, this is our B, right? This is our M, M equals 2, right? M equals 2, but let's write that as a fraction, 2 over 1. And our B equals 4. So remember, we begin with B. B stands for begin. B is our y-intercept. So it's our x. It's our y. So begin with 4 on the y-axis. We're going to begin. And then we're going to move. How do we move? Remember, this is rise over run. Rise over run. So this is going to be up because it's positive, and then to the right. Up to right 1. Up to right 1. So let's see. I've got up to... Oops, I'm off my screen. So instead of going up to right 1, up to right 1, if I switch this to negative over negative, I can switch this to be down to left 1. Down to left 1, down to left 1. Because negative over negative makes a positive, they're not really changing anything. So instead of going up to right 1, I mean, I can guess it's going to be right about there, but you can guess if you want. But let's just go ahead and see if it works. Down to left 1. Yeah, that looks about right. Down to left 1. All right, so let's draw our line. And don't forget your arrows. There we go. Okay, now let's tackle the second equation. Again, this is also slope-intercept form. We also have begin and move. Begin and move. So what is our M? Our M is negative 2/3. I'm just going to give the negative up top. You can give the negative to the 3 instead of the 2. One or the other is fine, not both. One or the other. And our B is negative 4, not positive. Negative 4. All right, so again, begin and move. Begin and move. We're going to begin with this negative 4 here on the y axis. It's a y-intercept. And now we're going to move. How do we move? If this is rise over run, but this is a negative rise. Negative rise means instead of going up, we're going to go down. We're going to go down 2, and this is still positive, so this is still going to the right. Down 2, right 3. Down 2, right 3. Down 2, right 3. So again, we start from this dot. Let's go down 2, right 3. Down 2, oh. Okay, so again, I'm off the page. I can guess. Let me just guess here. Down 2, right 3. But let's say I want to be a little bit more exact. So instead of going down 2, right 3, if I exchange this right here, if I put the negative underneath, like that, that's fine because that's the same thing. Positive over negative is a negative. But what would that change this? Instead of being down 2, right 3, excuse me, let me adjust this. Instead of being down 2, right 3, what we would have is, this is positive now, this would become up 2, left 3. And again, once you get comfortable, you don't have to keep writing it like this, you just do it in your head. So instead of down 2, right 3, I'm going to go up 2, left 3. Up 2, left 3. Again, I'm off the page, I'm just going to guess. And we'll go ahead and draw a line through these guys. Straight line. Put our arrows. So again, we want to find what is the point x and y that works for both. All of these guys work for the red guy. All of them. This one works for the red. This one works for the red. This one works for red. But this one doesn't work for green. This one doesn't work for green. This one doesn't work for green. This one works for green. This one works for green. But they don't work for red. Which is the only point that works for both red and green? And of course, by now you've guessed it, it's where they intersect. It's right here. This is the point of intersection. This is our solution. This is our solution. Okay, this is our solution. What is that point? That would be x is -1, -2, -3. So -3, comma, -2. -3, comma, -2. So that is the point that works for both, -3, -2. Again, we're not going to check it every time, but let's just do it for here, just for fun here. Let's plug in for x and y. You don't have to do it. You can just watch. So again, we want to think x is -3, y is -2. Does that really work? Let me plug that in. So x is -3, -3, y is 2. So let's see. What is 2? Oops, -2. Thank you. -2, -2. So what is 2 times -3? 2 times -3, that's -6. What is -6 plus 4? -6 plus 4, well, that's -2. -6 plus 4 is -2. Oh, and there he is over there. So it works for this one. Does it work for the green one as well? So x is -3, y is -2. Let me just erase these real quick. You can just watch. -3 and -2. So let me plug that in here. -3 and -2. Does that really work? Well, here we have 3 over 3. So this can cross off, become a 1. But don't forget, we had a negative here. It's kind of hard to see. We had a negative. A negative times a negative is a positive. Right? A negative times a negative is a positive. Positive what? Positive 2. So positive 2, this was a minus, kind of hard to see there. 2 minus 4. What is 2 minus 4? What is 2 minus 4? 2 minus 4 is -2. And what do we have on this side? -2. So it works for this one and this one. Again, this is the only solution that works for both the red and the green. That's when x is -3 and y is -2. That is our solution, and we solved it by graphing. Okay, so for number 3, I will let you guys handle this. But just remember, there's the 2 types. You have to be looking to see what type of strategy you need to do. Remember, we have slope-intercept, y equals mx plus b. And we have standard, ax plus by equals c. So ask yourself, is y by itself? And yes, it is. So for number 3, it looks like the top one is slope-intercept. And is y by itself? Yes, it is. So slope-intercept. So for both of these, it looks like we have y equals mx plus b. So we're going to do the begin and move. Begin and move for both of these. So for the top one, just write down what is your m. Looks like it is 3. Go ahead and write that over 1. And what is your b? It looks like that is -2. So remember, you're going to begin and then move, rise over run. So it looks like there's going to be up 3, right 1. Up 3, right 1. Okay, up 3, right 1. Up 3, right 1. Or down 3, left 1, etc., etc. Now for the second one, again, y is by itself. So we have y equals mx plus b. Mx plus b, so our m looks like it is -3 over 1, and our b looks like it is 4. Okay, so again, you're going to begin right here, and then you're going to move. Remember, because he's negative, you're going to go, instead of up 3, right 1, looks like you're going to go down 3, right 1, down 3, right 1, and then look to see which point works for both. In other words, look to see where do they intersect, where do they cross. All right, so I'll let you guys tackle that one. Number 4, again, let's take a look to see here. Number 4, what do we have again? Well, it looks like, again, y is by itself for this one. Number 4, y is by itself. So again, we have slope-intercept form for number 1. So it looks like you're going to begin and move. Begin and move. So what is your m for number 4? This number looks like it is, right, a -1. -1 over 1. And your b looks like it's a -3. And for the second one, looks like you have your m is a -7. -7 over 1. And your b looks like it is +3. So again, for both of these, we're not going to graph it out together. You can do that on your own. but you're just going to start and say, all right, I'm going to begin right here, begin at -3, right? Begin at -3 right down there, and you're going to move, right? So look at rise over run. Think about what a negative rise is going to be, right? For the green one also, you're going to begin this time at +3, and then you're going to move. So think about rise over run, whether we go up or down if it's negative, right? All right, so I trust you guys can do that. Let's take a look at these last two here, number 5 and number 6. So remember our two forms, slope, intercept, begin and move, right? Y equals mx plus b, and standard form. Standard form, ax plus by equals c. All right, so remember, slope-intercept form, y is by itself, and then we're going to begin and move. Standard form, x and y are together, and that's when we find the x and y intercepts. So let's see what we have here. For the first one, this red one here, well, it looks like finally, for the first time, x and y are together. X and y are together on the same side, so this one looks like it is standard form. Standard form. So we're not going to begin and move. We're going to find the x and y intercepts. How about the second one? We'll call him green. What's the green one going to be? Well, again, looks like we have x and y together on the same side of the equal sign, so that is also going to be standard form. So x and y are together, which means we're going to find the x and y intercepts. Now remember, thinking back, we have two ways to find the x and y intercepts. Why don't we do one with the red one and one with the green? Again, you can choose either way. To review, the two ways are to plug in zeros, plug in 0 for x, plug in 0 for y, or the little shortcut is just to take a, b, and c and just do c over a and c over b. So we'll do one with the red and one with the green. So with the red one, let's go ahead and find our x-intercept. Where does it cross the x-axis, right? Where does it cross this axis right here? So we're going to write it out, x plus, now instead of y though, we know that at the x-intercept, our up and down value is 0. Our up and down value is 0, so we're going to plug in that 0 right here. X plus 0, plug in 0 for y, equals -1. So this becomes 0, and we just get x equals -1. X equals -1. So our point is -1, comma 0. -1, comma 0. Let's go ahead and graph that. Again, that's the x-intercept. So it's going to be right there, -1, comma 0. All right, now for the y-intercept. For the y-intercept, same thing. We're going to plug in 0. We're still on this top guy, right? Still on this top guy. Plug in 0 for x instead. So x plus y equals -1. X plus y equals -1. Instead of x, though, we know at the y-intercept, what is my left and right value? It's always going to be 0. So 0 plus y equals -1, which means we get y equals, it becomes 0, y equals -1. So our point is 0, comma -1. Okay, where would that be? 0, comma -1. Oh, that would be right here. And then we go ahead and take our straight edge, and as straight as possible, we go ahead and try to make your line kind of long because you're not sure where it's going to cross. Make it long as possible. Go ahead and draw the arrows to show it keeps going in both directions. All right, and let's go ahead now and do the second one. I'll do it in purple because I used to always do it like that. So we have A, B, and C. You can do this method for both of them. I was just trying to show you both methods for this one. So remember, our A is 2, our B is -1. You could put a 1 there, -1, and our C is 4. So the shortcut that you learned to find the x-intercept, we just take C over A. C over A. So what would that be? C over A. C over A. So that's just 4 over 2. 4 divided by 2 gives me 2. So our x-intercept is, oops, 2, comma 0. 2, comma, 0. So again, that's on the x-axis. So 1, 2, right there. 2, comma, 0. 2, comma, 0. All right, how about the y-intercept? How about the y-intercept? Where would that be? Remember, that is c over b. C over b. So this number right here, 4 over negative 1. 4 over negative 1, that gives me a negative 4. So my y-intercept is 0, comma, negative 4. All right, it's on the y-axis. That's why the 0 is here. All right, the 0 is because we plugged in 0 for x. The 0 here is because we plugged in 0 for y. So let's do graph this. 0, negative 4. So this would be on the y-axis. 1, 2, 3, 4. There it is. Okay, can you tell where you think those two lines are going to cross? And let me go ahead and switch back to the green now. So our points were right here, 2, comma, 0. And right here, 0, comma, negative 4. Take your straight edge. You can tell it's important to have a straight edge now so that you can graph these guys correctly. All right, and there we go. We graphed them, add the arrows. So here we go. We got all these points work for green. This one works 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 for red. 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 They all work for red except the only one that works for green and red. Of course, the intersection is right here. Right here. What point is that? Right? Our solution, the one that works for both, is, what is that? We go over 1 and down 1, 2. So our x is 1, our x is 1, and our y is negative 2. Solution is x is 1, right? Our x coordinate is 1, and our y is negative 2. All right, so again, let's see how that works if we plug it in. You can just watch, you don't have to do it. So x is 1, y is negative 2. Let's see if that actually works. X is 1, y is negative 2. X is 1, whoops, 1 and negative 2. 1, that's a terrible one, but 1 plus negative 2. 1 plus negative 2, does that give me negative 1? 1 plus negative 2, yes it does. All right, and 2 times x, let me just erase that. That would be a 1. All right, so x is 1, we think. X is 1. X is 1. And y is negative 2. Keep switching on me. So 2 times 1 is 2. Minus a minus. Minus a minus turns into a plus. So 2 minus a minus, 2 plus 2. 2 plus 2, does that give me 4? 2 plus 2, does that give me 4? Yes. So again, the only point that works for both is when x is 1 and when y is negative 2. That is our solution to this system. And we'll learn other ways to solve it besides graphing. But so again, let's try this number 6 here. So we have a choice. Remember, we have slope-intercept. Slope-intercept, y equals mx plus b, begin and move. We have standard. Remember, that's ax plus by equals c. So you have to ask yourself, which one is it? Are we going to do begin and move, or are we going to find the x and y intercepts? So let's look here. The top one, the red one. Looks like x and y are together on the same side, right? X and y are together on the same side. It's not begin and move. It looks like it is standard form. And the second one, x and y are also together on the same side. So that is standard form for both. So we're not going to begin and move. We're going to find the x and y intercepts. Why don't we do the shortcut for both of them? Okay, so we'll do the shortcut. So we're going to do that A, B, C thing. So for the red one, what is our A? What's the number in front of x? Well, that's just a 1. What is our B? What's in front of y? Well, that's also a 1, but it's a negative 1. And then here's our C. So our x-intercept would be C over A. C over A. So that's going to be 4 over positive 1. 4 over positive 1. 4 divided by 1 is just 4. So our x-intercept is the coordinate 4, 0. Let's go ahead and label that. So we got the x-axis here, the y-axis here, 4, 0. That would be right there. Okay, now the y-intercept. The y-intercept. That would be c over b. C over b. So our c is 4. All right, we're still doing the top equation. We're not on the second equation yet. 4 over, this time b is negative 1. Right there. b is negative 1. So 4 divided by negative 1 is the same, except it's negative 4. Negative 4. So we get 0, because we plugged in 0 for x. 0, comma, negative 4. I should have boxed these up. All right, so our x-coordinate is 4, 0, because we plugged in 0 for y, even though this is shortcutting it, but we plugged in 0 for y. And our y-coordinate, our y-intercept, we plug in 0 for x, and we get negative 4. So let's go negative 4 on the y-axis. There it is. All right, so let's go ahead and graph these guys. Use your straight edge, put an arrow. So that is all the ones that work for the top equation. Every single point on this line works for that top equation. Now let's take a look at the second one. All right, so we are on the back here. Just want to get you started on some of these guys because this is a new concept. But let's take a look here at number 7. So I'm not going to do them all out for you, but this first one, let's remember, we ask ourselves, is y by itself or x and y together? Is y by itself or x and y together? X and y are together, which tells us number 7, this is in standard form. It's standard form, ax plus by equals c. So for standard form, I want you to find, again, right, our x-intercept and our y-intercept. And there are 2 strategies, x-intercept, y-intercept for number 7. So again, you can either plug in 0 for x and plug in 0 for y, or you can just do the shortcut c over a, c over b. So just think about what your a, b, and c are. You can put the number in here if you want. Or you could plug in 0 for x and 0 for y. Now I want to talk about this one right here because this one is an unusual case. Let's just remember what happens here. If there is only one variable, right? There's only one variable, one var. Remember, it's either going to be straight up and down or straight left and right. We have to remember if it's y, what does that mean? Might help to label your axes. Where would y equal 2? Where would y equal 2? Where there's one place, right here, right? Y equals 2 here. That's 0, 2. But remember, if y equals 2, then the up and down value, right? Because y is up and down like an elevator. Up and down value is locked at 2. Up and down value is locked. So you cannot move up or down from this value. You can only move left or right. So when it is y, you can just go left and right. Left and right. Like that. So you can just draw a line straight across. So the second one, remember, is just going to be a straight left and right line. I'll let you guys do the first one here, and remember the solution is the one that works for both, so just look for the intersection. These types of questions says, is 4, 3 a solution to the system? Is 4, 3 a solution to the system? And remember, a solution to the system. System means there's more than one, right? System means there's 2 or more equations. And in Algebra 1, we're just doing, that's a plus, right? 2 or more, right? 2 or more. 2 or more equations. For Algebra 1, we're just doing 2. In Algebra 2, you'll do 3. But is this a solution? Remember, solution means it works. It works for both. Okay, so how do we check if 4, 3, remember this is our x, this is our y. How do I check if 4, 3 works for both? Well, just plug it in. Just plug it in to both. All right, I'll do the red and green thing again so we can see clearly. So y, what do I plug in for y? I plug in this number right here, this 3. Right? So 3, it's a question mark. Put a question mark because we're not sure if it works. Equals 2 times x, which is 4. I plug the x in there, 4 minus 5. So let's see. Does 3 equal, let's see, 2 times 4 is 8. 8 minus 5. Well, what is 8 minus 5? That's 3. So 3 equals 3. Looks like it works. So this one works. How about for this second one here? Plug it in. So 3 times x. What is x? X is 4. So 3 times 4 plus, right, plus y. Looks like this is in standard form. X and y are together. That's fine. Y is 3 here. So plus 3. Does that equal, put a question mark here, does that equal 13? Well, let's see here. 3 times 4 is 12. 3 times 4 is 12. And 3, does that equal 13? Well, 12 plus 3 is 15. 15 and 13, so 15 does not equal 13. So unfortunately, if it works for the red guy, but it does not work for the green guy, it does not work for both. It does not work for both. So the answer is this a solution to the system? No. Right, it is not a solution. And that's all we can do. If it works for both, it is a solution.